Hello, today we're going to learn about the characteristics of functions. That will be two of our big ideas in our list of questions that we talked about the other day. One of the big ideas we'll be addressing today is question number 3, where it says, what is the end behavior like? That means as we go way, way out on the graph, what happens as we approach the ends? And then the other question is, how do we describe what we see? That's question number 4 in your list. What's it like? So how do we describe using math what we're seeing in these pictures? So I'm having lots of technical difficulties today, and I've recorded this like 8 times. So bear with me because I'm just going to get it done this time. So I have the notes already started here on the left-hand side of the screen. Also, you do have graph paper in your packet, so if you would like to cut little squares and tape them in your notes, that would be fine, or you can just freehand them if you would like to. So let's look here where we are talking about end behavior. So end behavior, to find the end behavior, you're going to start at the origin. The word origin means that's where you begin. So we're going to begin there, and we are going to head out to the left or to the right and see what happens to our y value. Okay, so let's start going to the left on this graph first. So if you look at this graph and see my arrow here, oh, there's the arrow. So I'm going to find where my y-axis is, where the origin sits, and I'm going to head to the left from there. So as I head to the left, I'm heading left, it's doing crazy stuff. I want to worry about what happens when I go way out here. So there's an arrow on the end of it, so that means it keeps going. Even though the picture is at the end of what we see, the graph is going to keep going, and it's going way up. So I have that typed right here. As x goes to the left, our graph goes really high. Now that's like the English way of saying it, so we need a little bit more formal language now that you're in Algebra 2. So here's how we're going to take that sentence and reword it so it's a little bit more formal. So as x approaches negative infinity, that means we're going to go to the left. So think about your x-axis. And as your x's go to the left, they go negative. As they go to the right, they go positive. So we are heading left, so we are approaching negative infinity. So we're heading that way. The next part of this phrase says that y approaches positive infinity. So your y-axis goes up and down, right? Well, up is positive. Going really, really high means you're going to positive infinity to infinity and beyond. And if you go down, then that would be negative infinity. So that sentence is saying the same thing as our English version that's right above it. Now, we do like to write things in symbols in math. We don't like to write out words if we can avoid it. So having technical difficulties with the screen. So we're going to do it this way. As x approaches, so here's your new symbol of the day. This arrow you read as approaches. That means it heads that way. As x approaches, let's see, and we are going to the left. So that's negative infinity. I'll label that left. So x-axis goes left and right. Left would be negative. So as that's happening, our y values are approaching positive infinity because they were going really, really high. So there's that word approaches again. And positive infinity, since our y-axis goes up and down, we would be talking about up. So that's our left end behavior. Go back here to this screen so we can see what's happening on the right end of this. So if I'm looking at the right end, go back to where my y-axis is, and I'm going to head right. So I can get, all I have is a cursor. Well, you'll just have to follow the cursor. It's heading to the right, and as I head to the right, what's happening to my graph? It's going down, really far down. So the way that, oh, wait, sorry. Oh, my goodness. Okay. The way we'll say it in words is as x goes to the right, our graph goes really low. That's English. We want it a little bit more formal. So we would say as x approaches positive infinity. So x's go left and right. If we are going to the right, then that would be positive infinity. And our y's are going down. So we would say y approaches negative infinity. I don't know what's happening with the screen right now. So All right, so let's write that in symbolism. So we said as x is approaching positive infinity. So that means I'm going to the right. What are our y's doing? Well, our y's are approaching negative infinity. So that meant they were going down. How low can you go? So those are symbols for end behavior for this first graph here. Another thing that I would like to talk about with this graph is where it is increasing and where it is decreasing. So let's see if I can add some text here. Okay, we are just going to go back to this screen and we are just going to write because it's not very fun today. So let's see, we're going to talk about increasing and decreasing. And we're going to look at this graph on paper. This is my backup plan. And it's not exactly like the other one, but it's close enough. We're going to be fine. Okay, so increasing means we are moving uphill. Moving uphill. Also known as positive slope. Show this a little better. We'll just keep it like this. Increasing, moving uphill, positive slope. So decreasing would be moving downhill, also known as negative slope. And it's important to remember that with slope, we read these left to right. So we read left to right when you're talking about slope. Okay, so increasing and decreasing. So if you look at this graph that we have here, I'm going to start on the left. So at first, what's it doing here? Well, it's decreasing. It's decreasing until I get to the x value of 0. Okay, so if I look forever this way until I get to the x value of 0, it's decreasing. And then it goes uphill for a little stretch. Remember that I'm moving left to right here. So it's increasing, we'll say until I hit that point. So it's increasing from where the x is 0 until 1, 2, 3, 4, 5, until an x value of 5. So we could say that it's increasing on the interval from 0 to 5. It was decreasing before that from negative infinity to 0. And then what happens after I get to 5? Well, it heads back downhill. So it's going to be decreasing again on the interval from 5. And it does that forever. So I'm going to put an infinity here. So it goes down forever. So there's increasing and decreasing for you. You're also going to see positive and negative. Where is the function positive and where is the function negative? So that means you want to look at where it's at according to the x-axis. So we're going to pretend that this x-axis is like a water line. Okay, so like this is water here. Everything you see above this is above 0 as far as the y's go. So that would be positive values of the function. And then if I move this, you can see the parts that are below 0 would be these parts of the graph. So you can identify the parts that are positive or negative by looking at where they are. If you think of the x-axis is like a water line. So this is water. Where's the graph above water? That's positive. Where's the graph below water? That's negative. So that's some more vocabulary you will see. Also, we will look at how high does it go and how low does it go. So there's some words with this. We have absolute maximum or minimum. Even my pen is dying today, you guys. Oh my goodness. So the absolute maximum or minimum would be the absolute highest point you ever see in this graph. Okay, so let's look and see if there's an absolute highest point. Well, see how this keeps going up and up and up and up and up and up and up. Are you ever finished going up in this graph? No. So this doesn't have an absolute maximum. Let's look and see if there's an absolute minimum. So I see it going down here. It curves back up, goes down, 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 down forever. So this doesn't have an absolute minimum either. Okay, so that would be like the absolute highest point ever in the world that you would get to. So this particular graph doesn't have those. There is like a bit of a high point here. It's not the highest point ever though, because the graph is higher over here. So that we call a local maximum. So like for its surrounding areas, it looks like it's kind of a tall place. Like if this was above water, this would be like the highest point on the island. But over here, there's like the mainland and it's way higher because it's got mountains over here. So this is a local maximum, but there's not an absolute maximum on this point. Same thing with the minimum. There's a local minimum here because it's kind of low here if you compare it to what's around it, but it's not the lowest ever because it keeps going down over here. So there's some vocabulary for you. Let me look. I think those are all of the words that I need to give you today. So you are going to have some work to do on on Delta Math today. So there are videos there if you would like to see their explanations of these ideas, since it was a little rough today with Mrs. Freeze. Sorry for that. And hopefully my technology will work better tomorrow and I'll have a better video for you. So I think that's everything. So have a great day and remember that Jesus loves you and so do I. So do your math.